Okay, I am going to start a brand new chapter, but I'm not going to cover all the sections. My main concern is to talk about what gas pressure is, and then go through some gas laws, and that's basically all I'm really going to cover in this chapter. So it's not going to be fully in depth, but just just so you understand the relationship between temperature, pressure, volume, and how it relates to gases. So here we go. Today's objectives, I'm just going to talk about what gas pressure is, and then we're going to do some pressure conversions. And so pressure is force per unit area on a surface. So how much force is being exerted on a certain area of a surface. And so it's going to be kind of a little bit of physical science 9 review, depending on who your teacher was. But force, the unit for force is a Newton. And so that by definition is just the force that will increase the speed of a 1 kilogram mass by 1 meter per second squared that the force is applied. So for example, if a person weighs 51 kilograms, they're going to exert a force of 500 newtons on a surface with their feet, no matter how they stand. And how we get that is you take the mass times the acceleration of gravity, 9.8 meters per second squared. So 51 times 9.8 is 500 newtons. However, pressure can change depending on that area of contact. So if I have both feet on the surface of the ground, and let's just say that the surface area of the feet are 325 centimeters squared, I would take 500 newtons, the force that's being exerted onto the surface, divided by the area of the feet to get my pressure, 1.5 newtons per centimeter squared. However, now if I'm standing on my toes, okay, both feet still, the area changes from 325 to 13 centimeters squared. So 500 divided by 13 is 38 newtons per centimeter squared. And now if I stand on just 1 foot on my toes, okay, I know it says 1 toe. I meant to say 1 foot, but you're still on your tippy toes. So 6 centimeters squared, 500 divided by 6, oops, it's supposed to be 6.5, roughly around 77 newtons per centimeter squared. So pressure can change depending on how your area changes. So here's a ballerina that I think your book uses as an example, and I just kind of broke it down. Now remember, pressure with gas is collisions. It's brought on by collisions of gas molecules with each other as well as the surfaces that they come in contact with. So if you take a balloon and you blow air into that balloon, the air molecules inside the balloon they're colliding with each other. They're colliding with the surface inside the balloon to keep that balloon inflated. So it's actually gas pressure that's keeping that balloon inflated. And so pressure exerted by a gas does depend on the volume, its temperature, as well as how many molecules are present. And so this entire chapter we're going to kind of go through what happens when you change the volume, what happens when you change the temperature, what happens when you change the number of molecules present, what happens to our overall pressure. So atmospheric pressure is the sum of individual pressures of various gases in the atmosphere. We tend to use a lot of different units. Pascals is the main one. That's the SI pressure unit. But we have millimeters of mercury, atmosphere, torr. But 1 atmosphere is roughly 10.1 newtons on a centimeter squared area. We also use an instrument called a barometer that can measure atmospheric pressure. And if you ever come across STP, or standard temperature and pressure, they're just saying 1 ATM, oh gosh, please add an M here, 1 ATM, 1 atmosphere at 0 degrees Celsius.
A barometer is a device for measuring atmospheric pressure. The simplest type of barometer uses a transparent tube, usually glass, which is sealed at the top and filled with mercury. The tube is inverted in a bowl of mercury. When the air pressure is high, the mercury is pushed up the tube. When the air pressure is low, the mercury is lower in the tube.
Okay, so these are the different units that you may come across in your assignment today. So here's that barometer, that mercury barometer. Yes, the atmospheric pressure does exert force on that mercury that pushes up the mercury inside of a vacuum tube. And so they actually measure here 760 millimeters of mercury. And so there's where that unit comes from, millimeters of mercury. So here's some other units you may come across. So we're actually going to do some sample problems where we're going to convert from one unit to the other. So I'm going to revert back to the slide a lot. So let's take a look at the first two, and I'm going to get my pen ready. All right, so it says convert the pressure of 1 atm to millimeters of mercury. So you start with what you're given. In this case, 1 atm. So I'm going to write 1 atm. And we're going to set up some conversion units. I need to get from atms to millimeters of mercury. Now, your book may have different tables, but I'm just going to use the table that I have here in my PowerPoint. And you notice that with my atm, it doesn't go straight to millimeters of mercury, but it does go to pascals, and then I can use pascals to get to millimeters of mercury. So I'm actually going to set up two conversion factors. And so for this first one, I'm going to put 1 atm on the bottom and ask myself, how many pascals are in 1 atm? So if I go back to this previous table, 101,325, so 101,325 pascals are in 1 atm. So pascals is kind of a small unit. Okay, so I'm in pascals because my atms are going to cancel out. And now I can get to millimeters of mercury. So again, I'm going to revert back to my table. And I'm in pascals, and I want to get to millimeters of mercury. So I'm going to put 133.322 pascals to 1 millimeter of mercury. So pascals will cancel out, and my unit will be left in millimeters of mercury. So 1 times 101,325 divided by 133.322 gives me roughly 760 millimeters of mercury. Okay, the critical pressure of carbon dioxide is 72.7 atm or atmospheres. What is this value in millimeters of mercury? Okay, so you start with what you're given. And I need to get to millimeters of mercury. Now, my problem up here, I went from atms to millimeters of mercury, so I can use the same conversions. So I'm in atm. That means 1 atm is going to go on the bottom, and 101,325 pascals goes on top, so my atms will cancel out. And then I set up my second conversion factor, where 133.322 pascals is equivalent to 1 millimeter of mercury. So my pascals will cancel out. I'm going to multiply and divide across. I actually get a really, really big number because it's 72.7 atms. Looks like 55,252. Millimeters of mercury. Don't worry about SIGs. Okay. All right, the vapor pressure of water at 50 degrees Celsius is 12.33 kilopascals. What's the value in millimeters of mercury? So you start with what you're given. I'm in kilopascals. So I'm going to go back to that table. Sorry, I just forgot what I was doing. Kilopascals and millimeters of mercury. So here's kilopascals. I can get from pascals and then from pascals to millimeters of mercury. So 1 kPa is equivalent to 1,000 pascals. So 1 kPa is equivalent to 1,000 pascals. And then I want to get to millimeters of mercury. And if you remember, if I'm not mistaken, it was 133.322 pascals. So my pascals will cancel out, my kilopascals are going to cancel out. I multiply and divide across, and I get about 92.48 millimeters of mercury. In thermodynamics, the standard pressure is 100 kilopascals. What is this value in units of atm? Okay, so again, I'm in kilopascals, so what you're given. And I've got to get to pascals, and then from pascals to ATM. So I know this first conversion. 1 kPa is equivalent to 1,000 pascals. And now I got to figure out my second conversion. So I'm going to go back. We need to go from pascals to ATMs. So here's pascals. Here's ATM. 1 ATM is 101,325. So 101,325 pascals is equivalent to 1 ATM. So my kilopascals will cancel out, my pascals will cancel out, my unit will be an ATM, I multiply and divide across, and I get roughly like 0.986 ATM. So I believe your assignment is 5 or 6 conversions. And there's already a table on the worksheet, so you don't have to look up your own. You can feel free to use that table or use the table here or use a table on Google, whatever table makes you feel more comfortable doing conversions. But all we're doing today is pressure conversions. Okay, so tomorrow I'm going to talk about the gas laws. A little bit more math, but this math is super, super simple. Not really conversions, just plug in, figure out your missing variable, and go. Okay. Oh,